We've got a panel here. I've already introduced Kevin, so everybody knows Kevin. In the center is Pat Jacobs, and many of you know Pat is graduate of Michigan State University. We won't hold that against them. School of Natural Resources. Patrick joined Heath in 2007, starting out as a field service project manager and quickly transitioned into a new role as sales consultant. Patrick's success in that role is what got him promoted to national sales director, and now his current position of vice president of sales. His responsibilities including directing Heath's domestic sales team, collaborating with the executive and engineering teams on new product development, marketing, customer service, and instrument repair. And I got to credit Pat a lot. Pat actually was living in Detroit, Michigan, running our MishCon DTE contract leak survey. And he'd done that for a while, and I was looking for a new salesperson at the time, 15, 16 years ago, and convinced him to move to Reno, Nevada, where he's still living today, move his family, that with young kids, boy and girl, his son and daughter and wife, who was real close to family in Michigan and everything else. And it turned out all right at the time. I don't think Patrick, but I told him the West Coast, you'll love it out there. It's beautiful. But he left it and has done a fantastic job. And we got another Patrick. We call him Patrick J, and then Patrick T. That's Patrick Thompson. And so Patrick has over 15 years of field management experience in the utility industry. He joined Heath in 2022 as general manager of operations, and in a short period of time improved efficiency while managing Heath's field operations. Patrick has an extensive background in the industry where he has managed labor, material resources, marketing strategy, territorial operations for companies focused on locating underground facilities. Patrick attended Florida Community College in Jacksonville, served in the U.S. Navy, thank you, where he earned the rank of Petty Officer First Class E6. During his service, he received several U.S. Navy degrees in electricity, electronics, and leadership. And so what we kind of want to do in this panel is just kind of talk about the turnkey. And so we've got different perspectives. We've got our VP of Engineering that actually was involved in the development of the product. We've got Patrick Jacobs that runs our sales team, and so but with background in leak survey and how we run the Discover AMLD, and then Pat Thompson that runs our field crews. And so all of our contract side of our business, whether it's leak detection, underground locating, meter reading, or meter services division, is all under Patrick T's responsibility. So with that, I think I'd just like to kind of open it up, Patrick, to you. And what does the turnkey mean to you? As far as the Discover AMLD and the whole process behind our turnkey offering.
Yeah, I think the unique thing, when Discover first came out, me growing up doing traditional survey, I looked at it like, really? Is this thing going to find leaks? It's on an angle. And so then, you actually go out there and see that it works. And then, over time, as we started doing demos, we learned, to do the investigation portion is very important. And so, our U.S. sales team, most of them have leak survey background. So when we started doing the demos, we realized, using the RMLD, you can quickly find the source. Using the dipper, you can quickly center it. And, then towards the end, we said, hey, maybe even if we could start pinpointing the leak with some pinpointers, and then if we had software or had technology that we could actually send that pinpointing right to the repair crew. So that's what turnkey means to me, is like totally transforming leak survey to what we knew it was, and actually showing the validity of it and showing efficiencies of it. That's what it means to me.
Okay, and I know, Kevin, you talked about the product itself, and then Steve came up with the software. And so, part of that turnkey offering is and I know there was a couple questions posed about, with the handheld equipment, and that all has its own piece of software, is, how we tie that all together. So it's a seamless cloud-based where all the information is in a central repository.
Yeah, exactly. So I think, on my part, turnkey means to me is not only having that right product, what we talked about with Discover AMLD, but the follow-up products as well with the RMLD and the dipper. And then a constant theme today has been data and what we do with that. And you can't build that and you can't have that data without the backbone of software. And that's why Steve was up here talking from Upstart 13 and bringing those guys on board with Heath, because we needed a best-in-class software provider to do what we needed to do for this turnkey solution. So building on what we've already done and our mobile applications and our history and knowledge, we said, here, let's build a structure where we can do leak survey and actually manage that whole leak survey program or service that we're offering. So it goes back into what Pat was just talking about. You're going out there and you're doing the leak survey. How does that get recorded? How do you want it to get recorded? So the best route right now is to build something online solution. So that way you can keep overlaying all this product data and information, and you can start to record this, and then you have something usable for you as a company, and then your service provider, hopefully, from a Heath standpoint, we're out there doing that, and we're able to take it. And if you look at the slide that's sitting up behind us, there's multiple aspects along the way, but when you talk about products and data, those are part of every step, even all the way down to the reporting, because you're now using all that data, you're taking it, you're getting it out into a usable format for where you can go and actually do something beneficial to your company.
And then Patrick, I know there's a lot of, when advanced mobile first came out, there was a lot of concerns. Conventionally, walking surveys were done with parts per million instruments, standoff lasers, pump drawn like the DPIR, laser-based technologies, and things were in PPM. Now all of a sudden we're trying to push the envelope, and you had to be in close proximity to the assets at the venting points, to find those leaks. And people then got concerned if we start running our distribution system now with parts per billion technology, and now all of a sudden we pick up all these indications, how are we going to be able to handle all these? And so, Patrick, why don't you talk about some of the teams that we're developing now, as service offerings, with some of the technicians?
Sure. Turnkey, we view at Heath as trying to keep up with the changes in regulations, the changing environment. And Kevin talks about products and data. People are going to be an important part of that component also. So we're developing advanced training to match the advanced products, the advanced software that we're working with. Because that data and that software, or in an incapable hand, may not produce quality results. So we're changing the way we train people from the traditional leak survey walking technician to make them more forward-thinking and better trained with the advanced equipment so that they become more troubleshooters, more investigators than actually walking leak surveyors. And our experience at Heath, given how we put together our training programs, how we work with industry partners to make sure that the best practices are developed, that's what we're doing in developing Turnkey. And we've created a team of specialized technicians that we're going to train in this concept. Our team is called Heath Team 6. We were not able to use SEAL Team 6 for legal reasons, but I still wanted to keep sort of the Navy theme there. And the quick action, quick response, highly mobile, highly intelligent workforce that is initially going to run pilots for us as we continue to learn with our customers, but then also provide the backbone and support for any larger scale operations as we get them set up.
Good. Now, along the line is the find rate, the percentage. You hear a lot of horror stories out there driving, and we pick up all these indications, and we go out and we don't find anything. And some of that is the technology being used for follow-up. There are different types of technology, but there's all sorts of handheld equipment out there from all kinds of different vendors, different pump rates, different sensitivities, different training on how to use it. So there's training on the technicians itself, about how to go out and respond to some of these leaks. So everything is different. So Patrick, why don't you go into how we feel, our approach with using multiple pieces of equipment and the training is making us more successful on the find rate.
Yeah, our findings is going out with the RMLD first and searching an area. You can search an area very quickly, and then go into the DPIR, which is a 2-liter pump with a 1-second response time is probably the best way to do it. We found other technologies with half-liter pumps or under 1 liter you could potentially miss the indication. So your fine rate is not as high.
Cool. I'd like to kind of throw it out to the audience now. You know, one of the other concerns when you start driving and you're finding more indications, granted they're an indication. There's an indication of methane, and then with the ethane, there's a determination that it's not bio, that it's thermogenic pipeline gas. But I'd just be interested to hear, you know, the audience as far as, you know, their feelings on, and we talked about our, you know, immediate response where we can still, you know, get out and jump at indications without the post-processing, you know, if we see large amounts. But I'd be just curious from the audience on their feelings at their company of going out and finding these indications, but not doing them immediately, and, you know, following up hours later, or in some cases, maybe days later. You know, how is that looked at within their organization? Don't all speak at once. Oh, there we go, Rob. Yeah.
Speaking with our regulators and stuff, they want things more in real time, right? So if you get a bunch of indications. I know, speaking to people in California, they have like a 21-day window to, you know, ride with their advanced leak detection, get their indications, follow them up in the next 21 days. And speaking with our regulators, there's not really an appetite for that at this time, where it's more if you get an indication, they want to investigate it in real time. So that's one, I think, barrier that we'll have to work through in the future.
Andy?
Hey, Paul. In the 6 states that we currently have AMLD in, we've not had any jurisdictional issues with it. We explained to them, we're just gathering data at this point. And once we get that data, we're refining it and then doing our more focused leak survey using traditional equipment. And they understand that if we have to stop every time there's an indication, technology is not going to work. So they've been on board with it so far. I think Kansas is one of the states we're in that has not adopted it yet. They are required to approve it before you can use it. And several gas companies in that state are working right now to get it approved. But we typically try to investigate all indications within 5 days and meet that about 95, 97% of the time. We are currently, we have AMLD units in Texas, in Colorado, Tennessee, Mississippi, Louisiana, and we're working on Kansas right now.
Any other comments from any other companies?
And it's a key point. You know, we were talking a little bit during the break to some individuals, and how do you get the regulators on board? How do you get people on board for this new way of doing leak survey, right? With mobile and advanced mobile, you're now recommending multiple days of running your vehicle before you post-process data and you look at it. So you're holding on to these indications or potential, you know, leaks, if you want to call them that. We call them indications because they're not confirmed, but you're holding on to those for a few days. And what does that mean? Well, what happens if within that 10 days before you can go investigate something, you know, a catastrophic event happens? Okay, you can look at it that way, but then you look at it from another standpoint and say, well, if we didn't have that AMLD, that area was not scheduled to be surveyed for another year or two. So then what? That would have, you know, same thing could have happened in that year. We're trying to do it sooner, so why do you get punished if something happens in that short window where you're trying to do a follow-up investigation? So it's trying to change the mindset of people as we use AMLD and how we, you know, get it involved in.
No, and I totally get that, but from the opposite side, on an odor call, I'd ask the utility, you get an odor call, maybe it's a 10%, it's a real gas leak. Well, what if we just said, well, you know, you can have 5 days to respond to an odor call. Most of them are just dead cat, old garbage. And, you know, the regulator would freak out and say, what do you mean? Somebody called in and So I think it's that mindset too, is you're responding to odor calls within 30 minutes. You get a detection on a car and you're going to wait 5 days. It's hard to put those two together.
And under our program, Paul, we're on the real-time leaks. We're responding to it immediately. The car is not stopping. We're sending that to our indication team. It would be one of Pat's guys, and they're going to it immediately. That's kind of what we're doing different than I would say other people.
And as we match up the software, the procedures, the people, some of these scenarios aren't as scary as they may seem, right? We're going to be able to react very, very quickly to things. So we hope the regulators see that we can improve on current response times by putting together our turnkey program.
So I'm hearing sort of two separate use case scenarios. One being an immediate indication, which is followed up by an immediate investigation, and another is a several pass drive that provides very accurate indication data through a back-end process that's followed up within a certain amount of time. I'm just curious if there's a sort of understanding of how those two different systems would go together. Just because, if I'm stopping at every indication, then what's the point of doing the back-end processing and driving everything multiple times? Like I understand that provides you with more accurate leak indication data, but if I'm just gonna get an indication, just like I was doing a normal mobile, and get out of the truck and go investigate it, find it, pinpoint it, classify it, and, move on, then why multi-drive?
Well, our proposition is to not stop the vehicle, but have a separate team that does that response. So we feel we can keep productivity at a maximum, also indicate the data collection at a maximum by doing it that way.
And what we're doing on we call what high probable leaks, we're addressing those immediately. The other ones we're post-processing, and one thing unique about Discover, we can post-process within minutes. So if, so we can kind of do both, and within the real time, we know with the cloud coverage map what we have, and if it comes back as a high probable leak, we'll immediately address it. So let's say the ones that are not, we might post-process them, and we'll address them maybe hours or the next morning. So that's kind of how we're handling that.
How's it going? My question was in regards to the regulations and the regulatory groups and educating on what we are doing or what Heath is doing to have those communication or those conversations with our regulatory groups to discuss, the difference between when you are doing a leak survey with a AMLD, for example, and you are doing post-processing, we don't know that there is a leak unless it exceeds a certain threshold or you're in your live detection. So at that point, you have no way of confirming that there's a leak, whereas when you're doing a walking survey, you know that there's an indication here, so then you're obligated to stop and investigate that. It seems like with more emerging technology, as it comes out with different innovations, we're pushing and changing the industry on how things are done. What are some pain points that you guys are seeing as you work through different regulatory agencies, and what are some things that us as LDCs can do to help assist in those things, or work with our regulatory agencies to bring this new technology to the forefront?
It's more of a regulation and process wise. I think a lot of it, you probably ask Pat what he's doing to meet some of that. And every industry association and everything you saw on the board this morning is exactly what we're facing. And Paul, Pat are going to these things and they're talking to people. They're helping to build the requirements behind the instruments. That's where you got to now the 5 ppm sensitivity instrument for detecting leaks, and then you have the 5 ppm for the standoffs. We're key parts of that process, and talking to the regulating bodies and the bodies that are making these standards out there, not because it's something that we require in our products, but it's something that the market requires for accurate detection. And then we are building our process around that and our training differently to kind of meet that need along the way, especially as you get into yearly surveys and you have these ever-changing conditions in growth in communities and gas consumption and constant changing of pipes. Every instance is different, and I know these guys are up for way more of a challenge out in the field with the people part of it. But I think just getting in front of all the associations and helping to be part of the rulemaking and what is needed from a technology standpoint, I think that's our biggest thing that we're working on and toward.
Could you say that part about the people again?
And obviously, more and more pilots we do, we learn more. I mean, we have the outline, and we believe the philosophy is good, and we're filling in some of the blanks. I mean, we don't have all the answers, but I think the more and more pilots do, the more data we collect, the more as we go on, we're learning, some of those things.
You kind of spoke to the mindset earlier about changing people's minds on how things are done. And, with new technology, the mindset on previous leakage equipment was there's a lot of false positives with hydrocarbons, whereas now you have equipment that's tuned specifically to methane and it's more accurate. So, as an industry, do you see there should be a need of getting away from specifying false positive versus identifying there was an indication 100%, it's just we couldn't duplicate it or find it at that moment?
Yeah, I think that, from a standpoint of false positive versus did we find the leak or did we not, right? That's the main thing. And as we mentioned in some of the changing conditions, you could go out and do a driving survey at night. You can find a leak with the Discover or find an indication. You could send somebody out immediately at that point in time, and you're going to find the leak. The next morning, it might not be leaking because it might not be on. So I think what you're talking about is the changing of mindset with this new technology is going to have to be people seeing it. So yes, do we need to get away from some terminology around false positives and this and that? That is probably something we should all kind of do from an LDC standpoint. From an engineering standpoint, from a product reliability, you look at those things. You go out and you test those things, and you try to beat it up to the point where you get down to almost zero false positives from a technology standpoint. From an LDC, it would probably be beneficial to understand that, it might not be a false positive that we're looking for. It's just, was the leak found or not? And at the end of the day, getting in front of the regulators and letting them see the technology actually happen, letting them see the follow-up survey, done in what we're trying to do with the immediate follow-up with the RMLD, and then the pinpointing and localizing it. I think, proof is in the pudding, right? When they see it, they're believers. So that's kind of the first step that needs to happen.
Yeah, about 6 months ago, we stopped abandoning videos and doing PowerPoints. So started putting people in the car and said, we're going to show you, so. And I'm not a big PowerPoint person. Anybody knows me. I'm more of a show you kind of guy, so.
But along your lines, I think it is right. I mean, a lot of people, even Mary talked about carrying a Detecto Pack 2 around her hip. Back in the FID days, and you're absolutely right, the FID saw total hydrocarbons. So we were picking up other things besides pipeline leaks. We were picking up, other hydrocarbons, things that were poured in sewers by people that were not natural gas related. People used motor oil around the riser to kill the weeds and all kinds of crazy stuff that you'd pick up and have to do a lot of work. So we went away from that, went to laser-based technology, optical infrared technology, still parts per million, but now we were only looking for methane. And then we had portable devices to look at the ethane part, to differentiate between thermogenic and biogenic. And so we've come a long ways, but then there's some believers out there that think that that equipment wasn't sensitive enough and that all kinds of leaks were being left out there, with some of it. And that's not the case. I mean, what we're doing on advanced mobile with parts per billion is to push the envelope on the inspection, to see a much larger swath of assets and, not have to have boots on the ground, walk 100% of the assets, and then on the majority of the assets, not find anything, and then you got workman's comp issues with walking, trips, slips, falls, dog bites, all these other things. So is there a better way to utilize our resources, with technology that can, cover large areas quicker, faster, and then only concentrate the efforts on those areas where we pick up indications? And Kevin's right, there's burping regulators if you go by. I mean, we've all had scenarios on large commercial industrial boilers that call for gas and vent gas and don't ignite. And, there are other things out there that it's not that it wasn't natural gas, it was, but at the time you drove by and picked that up, when you go to investigate, it's not delayed ignition anymore, And so it's not that it was a false positive, it was a positive. It's just at the time when you went to investigate, it's not there anymore, so. The other question, any other questions on that?
Yeah. I got one.
Yeah, Shane.
So kind of going back to the response and the Team 6, we talk about we have to make 2 passes, right? So when is the Team 6 going to respond, and what are they going to respond to? Are they going to respond to a certain threshold, or are they going to just respond to everything every time you get an indication? Or, You know, because you have to make at least two, or at least four passes, 2 drives, or 3 drives, 6 passes. So when is that point, right? And when we have this conversation with our regulators and we about weight in the leak, so that first pass going to be the one that we look at, or is the second one going to look at, or is the third one, or the fourth one, right?
Well, I think the first pass can produce a indication that requires immediate investigation. So, and we can obviously set the thresholds, the parameters on the equipment to, you know, what is proper and necessary. So the second pass will give us additional information, but we've driven just in some demos 1 pass and found immediate indications that I think our last one was 7 for 7. We found leaks. So the necessity to drive it multiple times isn't imperative to do immediate response, depending on how we've got the parameters set up on.
Yeah, to that point, you know, you look at the ethane identification, and that's really what you're looking for is, you know, you can make 1 pass, and if you make 1 pass down one side of the road, wind is favorable, and you get that ethane indication, and you know it's natural gas, that's an immediate, we're gonna go look, we can go investigate. And then as you have the indeterminates along the way, you come back and you make your second pass along that road, all of a sudden that data now gets integrated and you have more of a conclusion to that. Where you want to start making the additional runs, you know, day after day or whatever, you start really gaining more on the quantification side of things and even get more data to support whether it's natural gas or not. But that's where you really, really benefit is the quantification side. But the technology and Discover, just making a pass down the road, like we mentioned from a standpoint better than OMD, better than the optical systems or the Dipper mobile, you're going to get immediate detection. And if that ethane signature is within the rise in methane as well, proportionate to whatever that gas is, you will have a high confidence natural gas indication, which can be followed up immediately.
Yeah, Rob.
Quick follow-up on that. For the immediate indications, they're all based on volume of gas that it's picking up, right? That's what would give you an immediate need to investigate. You're saying, you know, the quantity of gas that it's picked up, you'd send somebody out to?
So it not per se the quantity, because sometimes you can have a small leak far away or a small leak close or a big leak far away, and you're going to pass through a plume signature. So I'm sorry, I can't see you here. But you know, if you envision the vehicle driving through and you have a cloud of natural gas in front of you, as you drive through it, that cloud is dispersed. So you're going to pick up a little bit here, and you drive through the main part of that cloud, and then it goes down to a bell curve. So what you're actually picking up is sort of a concentration as you drive through, not per se volume.
Any way to get an indication from distance to a structure? Because I think that's one of the biggest, from a safety perspective, right? Did I leave a type 1, grade 1 leak behind, or a leak that's in a manhole that I would investigate immediately on my indication? Right now, like Con Ed, we use DPIR, right? So if I get an indication, I check it, I have a leak in a manhole to type 1, leak by a building to type 1. Would there be any way for the equipment to trigger like the indication proximity-wise to another structure? Because that would enhance the safety, immediate safety value, I think, a lot.
So that's something we're looking about future-wise, and we talk about the software that we're building, and we're talking about machine learning and AI. Can we utilize that in post-processing to then bring in open map data and get that kind of information? Because we already do localization, not in real time. So in real time, we're driving, you can get an indication, and you get a source direction. We can say, it's over here. That's where the team can go out there and immediately knowing that they have the assets on their tablet, they can say, well, if it's coming from that indication, we're gonna go source over here, right? They're gonna be investigators at that point in time. If you make multiple passes and you do the post-processing, that, like we talked about, not only do you start getting better on your quantification estimation, but that's where you get localization of the leak. Are you able to sort of pinpoint it to a 10-foot radius? No. Can you give, you know, that cone, or, you know, a basic, yes, it's going to be within this 50, 60 feet here based off of these conditions? Yes, and you'll see that in some of the examples that we put up today. You have the purple kind of indication zone. You'll see some of them are a little bit smaller and some are a little bit wider. Well, based on conditions and what we picked up, there's some uncertainty in there. So sometimes you may get that indication, purple spot that covers a house or two where that is going to be at. And sometimes because the signal source is so strong and the plume that you've gone through is such a strong and defined plume, with a certain wind condition, you can very much get it closer to where it's going to be. But pinpointing exactly if it's up against the structure or not is going to be indeterminate.
Are they actually running a second truck that's just ready to, if they get an indication that's strong enough that they want to work it right now, that they would just go ahead and have a second truck right there with maybe a DPIR as Patrick was suggesting?
I don't believe anyone's doing that right now. We're showing them, we're basically rolling this out and showing them the whole philosophy behind it and doing that. But I don't believe anyone's doing that today yet.
Yeah, I think the earliest they do it is the next day.
Yeah. But like when we do our demos, that's how we demonstrate it. If we were to come out and demonstrate it for you today, we're gonna run 2 vehicles. We're gonna have the Discover, we're gonna have a leak indication team, and that's how we demonstrate, hey, here's the technology, and then we put people in the other truck and we follow up and say, look, here's the leak.
Why not do that now?
Well, as we're selling it, as they implement it, that's what we're showing them, that, hey, this is how we would do it. This is how he's gonna do it. I can tell you that. That's how Pat's team's gonna do it. And we're demonstrating, hey, if I was a utility, this is how, we would do it.
Makes sense to me.
Yep, absolutely. No, I agree with you. I mean, if I was a utility executive, that's how I do it today. Yep,
I just got one question on that. If you're doing it all at night,
we're not always.
well, and I guess that's the thing, because I've heard a lot of people say, well, we're going to drive it at night, less congested roads. Well, you start pogoing outside my bedroom window at 2 in the morning,
No, yeah.
people are coming out and say, I'm from Canada, I'm coming out and saying, hey, what you're doing, but other people are coming out shooting. You know what I mean? So I think there's some logistics on, I'm going to have the hit team right beside at 2 in the morning.
We've been doing our last, John, our last 5 demos we've done during the day. So, yeah, we haven't been always doing it at night. And you don't have to do it at night. The condition's always best at night from an engineering standpoint. But to your point, yeah, I mean, you do that in northern Nevada, you're gonna have some problems. Yeah.
Is there a question over here? Yeah, because one of the other things I wanted to ask and get feelings back, from a utility perspective is now that you're driving advanced mobile and now you're covering areas that you wouldn't normally conventionally walk, and I'm talking downstream of the meter. And so you've got apartment complexes that are master metered, that now have piping downstream of that meter. You've got homes that have metering, and then downstream behind the house has, has gas grills, pool heaters, spa heaters, all these other things. So now these are other indications that are real. They've been confirmed to be pipeline gas. And so just curious on some of your feelings on those types of scenarios. And, we all in the industry have a procedure. Obviously, if we find a leak beyond the meter, we shut them off, and then they hire a plumber to go out and find the leak, fix the leak, pressure test, and then you turn the service back on. But it's a good thing because you're finding these indications, not just from a safety standpoint, but from a environmental standpoint and stuff. But because you're covering more assets that weren't necessarily under jurisdictional, now it's just curious what your thoughts are on some of that. Why it's coming up is you're starting to see now, there's other layers. We talked about satellites. We don't own any satellites, and I can't honestly say that Heath isn't close to launch any satellites unless Carolyn is interested in doing that. But we aren't. But we are talking to the Satellytics of the world and the GHG sats and all the players that are out there. And there is a place for them. And then the aerial platforms, the helicopter, fixed wing type, and what a lot of people are fearful of. And Sean Epps and I have been at a lot of environmental shows and Roy, I know that you'll hear from tomorrow, a lot from the upstream side and some of the big majors, the ConocoPhillips, the Exxons, all these, none of these people want to be seen on front page news. They don't want to have a super emitter, and I'm talking super emitters that are unlike anything we'd see in distribution, because it's unodorized gas and things of that sort. And so these satellites are finding things like that, and they're also finding leaks downstream of the meter and stuff too. They're finding rooftop warehouses, these big Amazon distribution centers, and things that you as a distribution company would not go up on the roofs looking for these assets, and now they're finding them. And then how do you follow up on some of these indications? So just curious on some of your thoughts on that. I mean, with smart metering now, I mean, that's the other piece, is that, you know, now you have hourly, daily consumption records. You have historical records on gas consumption by day, by month, by time of the year, by all kinds of different things. And so, you know, I mean, if in fact there are losses downstream of the meter, and, you know, rightfully you have those records and stuff, you know, it's just, I mean, there's still a lot of master meters. There's a lot of states that don't have any left. They've taken them all, and the utility have gone in and repiped, you know, and put individual meters to each of the structures. I know there's a lot of military installations, and some when the government got out of the gas distribution business and said, you know, we're gonna let the local distribution company take it over, and they did, but, you know, they didn't do it for free. I mean, they came in and put piping and meters and, you know, and took the whole thing over, because they weren't gonna assume the pipe that was already there from a liability standpoint. But there still are a lot of master meters out there today, so, which you're now gonna find indications as well. Or even if our teams go out, we will find those indications as well. So,
Yeah.
just thought.
Is there a question in there, Paul?
Yeah, I was just, it's, you know, that it's, and I was getting on that point on the upstream side, and you'll hear some of it from Roy tomorrow, but that is a big fear of, everybody, you know, knows their system and has, you know, particularly on the distribution side, I mean, we have pressure monitoring, and we have a lot more control than the upstream side of the business. And, you know, and now with all these different, I think, you know, it was talked about, earlier, you know, about there are environmental groups out there that are running around with equipment that are actually finding leaks and stuff, and then and then letting, you know, local news media and stuff. You know, Mary mentioned that. I was at a deal, and I was actually here in Dallas just a few years ago when EPA was coming out, and there was Mothers Against Methane, and there was about 60 of them, and they had red T-shirts on with white lettering that said Mothers Against Methane. And they had billboard trucks running around the city hall, and they were all over the place, you know. And they had acquired, not Heath equipment, but they had acquired some optical gas imaging cameras, and they were running around saying, you know, if you can't get the local, you know, gas company to do it, call us and we'll come out for free and we'll find and determine if it's a leak. So now you got a bunch of untrained, non-operator qualified, you know, people running around that have no idea really how the equipment works and what they're doing, but, you know, it's real. I mean, it's some of the things that are happening today. So.
Yeah, just going back to your question of about 12 minutes ago.
Yeah. All right, Rick. I love it.
Con Edison, New York City. So we're, you know, we did deploy AMI, and our gas meters are AMI capable, and now we are bidding to explore analytics on that metering data to see if we could identify usage anomalies, leaks, equipment left on, right, water heaters that are leaking, and of course there's no more zero at the meter, right? It has a constant usage because the water heater's calling all the time. Gas barbecues left on, guilty, done that. So you know, we are looking to you know, enhance the customer's benefit by AMI meter reads. Right? We don't expect really to find a lot of leaks. We have a natural gas detector program. Spoiler alert, we're going to talk about that. So it's really just about really reducing carbon emissions unnecessarily, right? Unnecessary combustion.
Any other comments? Kevin, you want to talk a little bit more on the ML and the AI side down the road? I know Steve touched on some of it, but what do you kind of envision down the road as the software is developed?
Yeah, so what we can see, and you know, all this is information that comes back from the sales team, comes back from talking to you guys, right? It's what do you need, what's going to make your programs better. So we try to take that, and we try to take what we're doing in-house as well and say, all right, what would be the next beneficial thing now that you're collecting all this data, you're putting up in the cloud, you can overlay your assets, you have more and more information being open source with OpenStreetMaps and things like that. How can you start building a better program? And one of the first things that we always get asked from people is, well, when you're driving Discover, can you automatically grade these indications, right? Where do we know to go first? You can't, right? You don't know where they're leaking. You don't know how bad they're leaking. If it's up against the structure or 15 feet off the house, right? It's a difference between grade 1 and grade 2. So can we start to get better in the data that we process and the follow-up investigations and bring that in and do more of a risk-based approach, right? Is within that indication of source found, is there a school, a hospital, a business district, or a high occupancy area within 100, 150 feet of there, or maybe further? Depending on what you guys want, that can be variable, but can you start using that kind of information to say, we found this indication, it's now within a certain proximity, so maybe it gets a higher grade, or maybe it gets a higher risk score, that can be gone out and investigated sooner or faster, or any other way that you want to do it. So that's one of the things that we're kind of looking about for the future in terms of machine learning. The other thing is you kind of pair it with some AI, and you start to look at how can you take this, and people are doing it today from a emissions standpoint. You're quantifying emissions over, let's say, 5 miles of pipe in this certain area. Can you tell if that area of town is more leaky than another area, right? So you're looking at it from a rate case, you're looking at it from a pipe replacement standpoint. You guys are doing it now in your programs where you have your pipes and your systems, your construction management, SAP systems. You know how old it is. You know where it's at. Is it in bad soil conditions? What's happened? Has it been in a lot of construction? So you're taking that already and using that from a risk-based approach for pipe replacement. Can you now overlay all this emissions data that you're gathering through driving the AMLD, and can you incorporate that and make your programs even better? Can you, take all this information and get, again, more of a risk-based approach to pipe replacement? So you start doing that, you start generating heat maps along your infrastructure and your assets, and that's where you kind of come up with better use cases for what we're doing in follow-ups. So those are kind of things we're looking about. Again, always interested in hearing what you guys might have or what your needs are, because that's one of the biggest things that we're trying to do, and what Heath has been focused on for many, many years is addressing user needs. There's also the unmet needs that we're trying to address, right? And those are the ones that we see by going out with you and being a partner with you. And if we're out and seeing something and say, well, why did you do it that way? And if we can make that better, that's what we're going to do. So that's what we're trying to build into our software and what we're doing with the machine learning AI. But it's part of the process, and it's part of working with you guys as well as what you need.
Let me ask one to Patrick. When we're running the advanced mobile now, it can be difficult in some areas where you get an indication, the assumption is that it's one leak, but there is the possibility it could be several leaks in that same geographic area. So, Patrick, why don't you explain, of finding a leak versus finding the leak, of going further on the complete inspection, either PT or J, either one could answer. But the idea is that there could be multiple leaks within that indication. And just because you find the first one doesn't mean that is the one. And how you continue on in the investigation to make sure you've covered the full area in the event that there's another leak, or perhaps the leak that was worse than the one you found, because they were in such close proximity. It's just one plume.
Yeah, so let's say we find a grade 1, right? We don't just stop there. We continue to search. You do what, your 6-point check, and you continue to search a larger area. So, and then you might find, like Paul says, multiple leaks. So as we're building this new program and making this transformation, that's part of all the OQs and part of the new, leak investigators. So yeah, sometimes you think, or you think it's one, it's actually multiple leaks, but we just don't stop at the one. We search outside of that another 300 feet with the RMLD. That's why it's so crucial with the RMLD. Like some of our competitors are using just pump drawn instruments, and they're using the lawnmower effect going back and forth, and they potentially could be missing those other leaks. with the RMLD, you can search a 100-foot area. It's easily, you can search a wider area to find those other leaks, so.
And the scenario I mentioned before where we found 7 out of 7 leaks, it wasn't easy. We were relentless in utilizing all of the tools we had at our availability, as well as, our technicians' intelligence to chase down those leaks. So we think it's a matter of diligence as well as, using the advanced equipment.
Hello, everyone. John Simpson, National Sales Manager. I was just going to speak on behalf of one of the comments on day or nighttime driving. So I know we had a situation in one of the recent demos. We were actually doing a nighttime drive and collecting the data, post-processing it, and then following up on the following day. So we actually had one of those situations, and this is pointing more to the question where is it a false positive or are we just not locating that indication? So we did the follow-up investigation and we weren't finding anything. The system was pointing this as it was a medium concentration or a medium confidence natural gas indication. So we were very confident that there was a natural gas indication, but it was stumping us. We couldn't find anything. We did a very thorough investigation. So we actually came back up that following night, did another drive. Utilizing one of the tools, the RMLD CS, we were able to find an indication inside of the structure. So however it was actually venting and expressing itself, so the system was recognizing the leak. So what was happening was the owner of the restaurant, they were blowing out their pilot lights at night. So they're blowing out the pilot lights, the structure was filling with a natural gas presence and venting itself. So just to a comment, there are some anomalies that we were able to pick up just based off of a real-time investigation.
Yeah.
Yeah, I haven't heard it addressed, and maybe it's not a problem, but when you do have far-off type of leaks, I mean, methane 16, air's 29, we're doing something that's 2 feet off the ground, we have AMLDs and things like that. Do we have mixing? Is this contributing to a false? Is that maybe it's above where the sensor is? I mean, and if you could just opine on that a little bit, if it's not a problem, why it's not a problem?
I think it's always going to be a problem. You're eventually going to get a rise, which is why the recommendation, especially if you're doing post-processing or you're trying to get more localization results, is to run at night because the atmospheric conditions are beneficial. You have the air is a little bit more dense at night, which keeps the methane a little closer to the ground, so that way you are able to detect it. You are just naturally going to have incidences where you have leaks far off from the road that as it goes and as it gets blown, the distribution of the plume is going to be all over the place. It is going to rise. Again, why we put the Discover at a diagonal is to try to capture as much of that as possible versus just having it 18 inches off the ground and driving through because you could potentially miss something. At that point, though, you're also looking at the certain size of leak, and that's where you came up with the coverage or field of view, whatever you want to call it. And when you're looking at that, that's something you take into consideration because if you have a very, very small leak far away, it could very much dissipate, the plume could dissipate or rise to the point where you can go right past it and never detect it. But that's part of the coverage of the instrument and what the settings are. So I hope that kind of answers it. I think it's an unknown. I think that's something you always deal with any technology. And it's just something that from an operation side of thing and from an investigation side of thing, when you take that data and you put it up and you get the PDF report and you look at the coverage based off of what you know, you'll have gaps if an asset is present or if you know an asset's present. That's where the follow-up investigation team is smart enough to say, we're going to go look at the gaps as well, not just the indications. So those are where you're going to be able to find those kind of special leaks.
Have you ever found situations where you feel like you missed a leak because of still wind conditions? Because we're talking about surveying at night, and at night the wind is the calmest, and I get why you're doing that because the variation with wind creates uncertainty. But is there the possibility to miss something because you're in no wind situations?
You say no wind or just variable wind?
No wind.
Oh, definitely. Any of the advanced mobile technologies out there today, if there's zero wind, you have more of a chance of missing something as you pass by. You'll naturally have variations in the atmosphere, whether it be from multiple cars driving through or just the gradient of temperature. You have a little bit of movement, air movement, but for the most part, you might not get the most beneficial wind to actually detect, which part of the software takes into account. We will show zero coverage in and of that area. Will you be able to maybe detect a leak within 5-10 feet of the vehicle because of that? Of course, but because you don't have that wind blowing in that speed in that direction, we're going to show zero coverage over that spot.
Any other questions to ask the panelists? Shane?
I guess just to follow up on that, how many times in your demos and the testing that you've done have you had that situation where you have zero coverage? I mean,
There's on sides of the road, so if the wind was blowing in a certain direction, we've definitely made a couple passes and one side of the road would not be covered. As you expand and say, we're going to go with 3 SCIF or 5 CFH, you'll get a little bit more because you're gathering wind data, like Vineet said, at 4 hertz, so you're processing it all along the way, and wind is not linear. As you know, you go outside and you can look at a flag and it's blowing here and there. So you have all the eddy currents and everything, so you are getting some detections in and around the vehicle. But if it's a constant, south wind on that side of the street, you're not going to get detection over there. But if you drive the next street over, as you go over, you may get that indication. So that's where the coverage map, kind of has to get aggregated. That's why you also want to do multiple runs when you're really trying to look at localization and stuff. But from a standpoint of what we're trying to do with the real time and the turnkey, you can go out there, you can make sure you're detected from that standpoint, and then anything that's not covered, is a gap that has to be followed up anyways.